So National Center for Biotechnology Information is part of NIH. People have heard of NIH, I hope, at least. Yeah, okay. So I will ask a few questions first. How many people have played with cluster schedulers like Kubernetes, Nomad, Mesos? Like 30% of the people or so? I expected a higher number, but that's good. So how many of those are using it in production seriously? Maybe, I don't know, 7% of the people. Lower number than I expected, but that's still good. So that's definitely cutting edge, right? Within DevOps, which by itself is cutting edge in the software industry, cluster schedulers are also on the cutting edge. Another question, service mesh, how many people know what that is at all? I'm seeing maybe 7 hands or something like that. So that's maybe, I don't know, 5% of the audience or something. How many of those actually use that in production? And there's 0 hands. So that's bleeding edge, right? I mean, this concept appeared maybe last year. It was, in fact, last year. There was at least one product that predated the concept itself, Linkerd by Buoyant, but now there's more products. So this is definitely bleeding edge, but it's kind of the way, in one of the possible futures, for sure. I'm going to explain it a little bit. If you have 2 pieces of software that talk to each other through the network, you could have your business logic and you have your network logic in that piece of software, but nobody does that these days. You have a TCP/IP stack to rely on, including things like flow control and so on. But these days, when we're doing SOA and microservices, we have more things to worry about, like circuit breaking and other kind of retry policies and whatnot. And so it's not a good idea to really kind of bake that code within your applications, because you're going to be redoing that every time. So at least you kind of abstract it away as a library. But now you have to worry about updating that library everywhere and multiple languages and whatnot. So people have come with the idea of, you know, move it down the stack somehow. And you cannot really put it in the TCP/IP stack. But what you could do practically is have an external agent that does that for you. And it's essentially a proxy that they call the data plane of the service mesh. And then you have a control plane of the service mesh where you hook in your service registry or service registries. If you have multiples, you might have a hybrid situation, you might be transitioning from one thing to another. And then in that control plane, you also have your enforcement policies, whether it's security, whether it's routing rules, all of that stuff. So then, I'm sorry, I skipped a slide here. You hook in your monitoring and, you know, basically your observation into, you know, telemetry or tracing and all of that stuff in order to be able to not only control the service mesh, but also observe it. So this is stuff that Google, for example, has been doing for quite a while internally. They have the equivalent of Kubernetes. They have the equivalent of service mesh. They haven't really shared the code, obviously, but they're backing open source projects like Kubernetes and Istio. So that's one of the possible futures, and it's definitely something that we in our organization think that it's a good kind of future, and we are aligning ourselves with that future. So we're making a bet. And I'll talk a little bit more about this, but let me continue with the questions. Distributed tracing, and what I mean by that is, you know, you have a monolith, you have tracing, you have distributed system, you have distributed tracing. So you have pieces that are calling each other. You need to kind of pass the context so that you can see the whole trace. So how many people use such products in production? There's one hand over there. So there is open tracing. How many people have heard of open tracing? We have maybe 10%, 15%. Look it up. That's basically an API, and you have a number of products. I'm listing some here. You could see them on the website as well that conform to that API. You don't have to necessarily have a product that conforms to the API. However, if you do, then you could. This is a matter of how many products out there in the industry actually conform to that API. But the more they do, the more you could hook things together. So you could be observing not only your applications, but also third-party applications like, let's say, solar or something. That's definitely, it sounds like, on the cutting edge as well of things, since not many people even know about it. How many people work in the government here? I think there's maybe 10% of the people. And I'm asking that question because it's interesting to me how many people work in the government, and there's overlap with people that are using Kubernetes in production or something like that. It's probably not many. It's like 0. And then another question, ITIL. How many of you know what that is? There's a good number, maybe 20%. And I'm assuming that you're using it in your organization or you just know about it. How many are have implemented ITIL? There's one guy. So the reason I'm asking, there is an interesting maybe relationship between DevOps and ITIL. I think ITIL has some mature concepts that are, at least people should read about that a little bit. There's there's books and there's products, and I'm certainly not saying we should be doing ITIL, as in like adopt a product or strictly go with that. But what I'm saying, I guess, is there are some mature concepts there, and once whatever you're doing is mature, you would inevitably face the same problems, and so it's good to be thinking about it and how exactly you could address them, perhaps in a DevOpsy way. I'm going to answer the same questions for my organization. So NCBI is doing cluster schedulers in production. It's doing the service mesh in production. It's doing distributed tracing in production. We see the benefits. And we have seen them for a while. And we are a government organization. And what people ask me all the time is, how is it that you are in government and you're sort of, so high tech and so much on the cutting edge of things? The reason is, well, it's the way we're set up. We've been around for 30 years, and we're set up as a sort of like, it feels like a little oasis within the government where you have people essentially highly productive. They we have brilliant engineers, and we have a lot of freedom to innovate and build things quickly. And it's the opposite of what you might be thinking of in terms of like lots of bureaucracy or something like that. We have 0 of that internally. And so we have produced a number of sort of resources out there that if you're in the biomedical industry, you would be working with those things on a daily basis. And maybe even people here might have heard of PubMed, for example. Raise your hand if you, there's like, I know 7% of the people. So there are things like BLAST. So these things are either databases or services. BLAST is a service, for example, for comparing sequences or sequences against databases of sequences. So these are really mature, these are brands essentially well known in the industry. And we have faced exponential growth ever since we started 30 years ago. So the picture is always looking like that. And I'll give you a few examples. This is 3 of our databases. They're sequence databases. That's how it looks like in terms of growth. It's exponential. You can't even see before year 2012. If you switch to logarithmic scale, you would see the growth. If you look at the sequencing cost, and this is the reason why we grow so fast, it has been dropping exponential decay, but look at Moore's law, which is also exponential decay, and look at how they compare. So this is logarithmic scale as well, by the way. That's why you have like a straight line for Moore's law. But this means that you have a storage problem. And so we have like 100 petabytes of data, and it's growing. And what we're looking at is creative ways of how we share the cost with others on the cloud in order to even continue to be an archive of data. So that's one of the challenges we're facing. And we have other metrics, also exponential growth in daily users, and a few other metrics I'm sharing here. But in terms of things that are running inside the software shop, there are services and there are other things that are running like processes and so on. So we have maybe 2,000 to 3,000 services that are talking to each other. So you can imagine a really complex mesh of services. And you have 10 to 20,000 things that are running. So it's quite a bit. It's very mature. You have, we certainly have a service registry that we created before people were talking about even about service registries. The word was not even popular. So we have things like that. We want to get out of that business of building infrastructure ourselves in C++ or whatever. We want to use products, open source or otherwise. So that's one of the things that we have committed ourselves to kind of open up and start using products. And the other thing that we decided is we really want to focus on where we're adding value. So things that we could uniquely build and not worry about the rest of how we build things and how we deploy and so on. So this is basically where DevOps kicks in. And you have to have a DevOps solution of some sort. So because we have a lot of things that we're building, and they're all kind of built and tested and deployed in unique ways because we have a lot of freedom of how we do it. There's no like single SOP or some sort of process. People are basically doing things by themselves. The flip side of that freedom is that you have a lot of different animals to deal with operationally and in terms of like a portfolio. And there's a huge number of them, 10 to 20,000 things that are out there. And so if you take all of that and you kind of collapse it by building a single DevOps platform, this is basically how we believe we're solving our problem with cost. And we kind of make room in the budget to continue to build things. At the same time, we justify the cost of building a DevOps pipeline. So this is what we did. It's an organizational decision. Everyone does their own decision, but in our case, it made sense to create a group within the organization and make that group responsible for building and kind of, it's both a product and a service. We're servicing internal customers, essentially. And so we have full commitment organizationally to do that. And what we started with is, here's an easy way to deploy your application, click of a button pretty much solution that allows you to both deploy but also monitor your application in a very easy way. And what we saw is immediate kind of adoption. We had like 150 applications in the first few months adopt without even advertising too much to people. And then the big question, though, is how do you continue from here? You have the early adopters, the excited people, but then you have to deal with a lot of other things. And so first thing we did, we measured everything. We basically data mined everything out there to see what's out there. And we said, things need to mature into the DevOps pipeline. So bring everything here. But what is the plan? How do you do that? Do you do it in bulk? Or do you kind of make a project plan of some sort? And because we have organizational commitment all the way from the top, our leadership is technical, they fully understand it. and they're fully committed to the idea of we have to do this. So now it's a matter of project management of how exactly you organize it. And so you take that zoo of things, and the first thing that you do is define your products. And so you have people basically curate that list of things, and you have a number of products, you organize them like that. And the second thing is sort them out. So there's a queue. Essentially, you have, say, projects that are tier 1 project that in this particular quarter, and you start with that, and you help them. So you go product by product, essentially, and you focus on only a few, maybe one current, and then you take care of one customer, and then you only help them operationally afterwards, but then you move on to the next customer. And so when you have focus, you could actually build your pipeline one customer at a time by adding features that matter to them, and you're not really saying, you're not making promises to other people in the long tail of things. They certainly inherit the features as a side effect of you adding features to your pipeline, but you're not making promises, so you don't get stretched in all directions, demand of features and so on. It's a little crazy if you do it that way. So I would say we've been doing this for a year and a half, not too long, but we managed to organize ourselves pretty well, and now everything is sane. We don't go crazy by all the demand out there. And the other trick that we do is, as we are focusing on a particular product, we work with, we have chief architect, but you might have like an architecture group or something like that to kind of go over the architecture of the product, see if it needs some recommendation for improvement or whatever. And we DevOps work with, we go early, and we also look at the architecture ourselves. And what we do is we started kind of toying with the idea of, capture architecture as code. So because we're dealing with TPMs, they are technical people, they like YAML. So I would rather give you a little YAML file and update it every now and then when things change, rather than be touching documents and updating diagrams all the time. They really, they don't like doing that very often. But if I give you a little YAML file, I could basically have CI for, produce an architectural diagram from that YAML. And every time you touch it, I create the diagram for you. I also update my inventory. So now we know things in so we have we're building this warehouse of inventory. And also I could give you a dashboard where you could see your architectural components operationally. And so you have this incentive to keep your architecture updated. And the other trick that we do is also deployments. So typically you have multiple deployments per product, like microservices style. Maybe it's just one component that I'm deploying. You may have a group of components. With something like Kubernetes, it's declarative deployment. So part of that, if you declare your dependencies, I'm sorry, I skipped a slide. You also get a monitor with your piece and its dependencies. So you have an incentive to do that. And now you have two ways of capturing that architecture, and it's redundant, but that basically means I could QA it. I could check one versus the other, issue warnings that something is not up to date. And the other trick is you've captured the architecture declaratively, but you could also see the actual calls because we have distributed tracing. And so you compare the two, and a human can tell that something is wrong. There's like an extra call somewhere. Why is that? There's probably a library that's making a call and we didn't know about it. Maybe we should update our architectural diagram, or maybe we shouldn't be using that library or something like that. So that's another form of constantly be observing as things are evolving and keep them in a good shape so that everyone can see a current diagram. And when we're talking about distributed stuff, there's like, how do you do deployments? So there's this piece in the middle that I want to deploy. You guys are familiar with blue-green, I'm sure, It's like I'm basically introducing a sibling, and then I'm switching, I'm testing, and I'm switching my routing to it. So this could be done by simple routing rules. I'm switching from one version to another. Service mesh would help you there, essentially. Another form of this is canary deployment, which is similar but slightly different in that my service, my routing rules would be basically weighted between two versions, and I'm moving the sliders slowly as I'm testing, and so it's like a combination of real users and synthetic monitoring. And you have observation into a number of metrics. And if you go beyond CPU and memory, you have meaningful metrics like error rates and such. And so you could have thresholds of, if you go beyond some threshold, then you really should roll back automatically. And this should all be automated so that essentially it happens based on certain thresholds that you declared, and you only notify the humans when you get a rollback. If you really want to do continuous deployment fully without humans in between. By the way, how many people are doing Canary at all? There's three people, that's great. We have all the building blocks to do Canary. We don't currently do it, and it's a matter of like, what is the final workflow for the people? It's like, is it going to be Spinnaker or something like that? We haven't quite finalized. We're using TeamCity, but we have the building blocks to do it. And what we do currently is there is, your service registry, there is the routing table. It's essentially blue-green, but I want to emphasize one particular detail here. In just a second. Looks like I removed something from this slide, but notice that I have the ability to test my component there through another component. So it's like I'm not probing it directly, but I'm probing it through another microservice. And so in order to do that, you have to have two things. First, you have to have the ability to, for that particular request, say what foo would be, so point to another foo. So this means the request itself have local information about routing. And the other thing is it has to pass that information from call to call. So this is the same as distributed tracing. You have to pass distributed context. So the service mesh can do that for you. Linkerd does that for you, and the other products also have those features. They're in various degree of maturity, but it's a little trick that essentially you could be testing things much easier this way if you have really complex stuff. And what we call activation is essentially just a switch in the routing from one version to another, and the same thing would be Canary. So Canary would be basically your activation. Activation is our term, but what we mean by that is really, we have the delivery plus activation would be continuous deployment if you don't have a human in between. But you could have a human in between, still the two distinct steps in the pipeline, essentially. And this allows you to do really complex things. So if you have, maybe this is a picture of 3 microservices that 3 different teams deployed, but maybe it's a picture of 3 complex deployments. And before you activate them, you have a chance of like testing everything together. We have such stuff because we have so complex systems, and this is a solution for us because, look, I could really have any combination of things, any combination of versions of components living next to each other without actually bottlenecking. Because what we saw is our QA or staging environment becomes a bottleneck when you have a lot of changes. People are developing quickly, and they have conflicting versions that cannot live simultaneously in your staging. And so this is a solution for us. And from here on, I'll talk a little bit about, when we talk about operation, there is the topic of observability, which I think, the previous speaker talked about that. There are all these things. Observability is a number of things. So how many people can say that in production they do all of these? I asked about distributing tracing earlier, and I didn't get many hands. Let's remove that from the list, but are you doing substantial number of this at least? So I don't see many hands. It's like a few. It's like 10% of people are raising hands. So we ourselves are doing all of that, just maybe because we've been in this for a while and we have ways of doing it. And we're certainly modernizing our stack. So for example, for monitoring and business stats, we started using the tick stack. Login, distributed tracing, narrow reporting, we're using a homegrown tool that is pretty capable. Dashboards, we started using Grafana recently and Opsgenie. But this is not, I'm not advertising products here. I want to talk conceptually. And I'm going to bring the tick stack just as an example of a product that it's essentially multiple things. It's multiple products. They're nicely decoupled, and they do one thing well, and they have interfaces in between. So, for example, we substituted out the dashboard with Grafana, but we kind of like the other tools because they're just very capable. Telegraph, in particular, is a Swiss Army knife type of tool that can do a lot, and it supports a number of kind of standard interfaces like StatsD and Prometheus. So we really managed to kind of hook everything with Telegraphs. Now we have observability into our infrastructure, and our apps can also emit stats, StatsD, or they expose a Prometheus interface. So this is for business stats, obviously. And another tool that we like is Capacitor, also kind of a capable tool, which does not only stream processing, but also it could take batches from Influx, for example. And it can, out of the box, talk to a number of other systems, but you could do your own. And it can act as a deadman pedal as well. So sky's the limit of what you could do with Capacitor, really. And what we started doing is things like auto-scaling our services using the cluster scheduler based on metrics. We auto-scale the cluster itself, auto-heal. So if a particular instance of a service is not, there's some trouble with it, you just kill it, and you let the scheduler create another one. And then canary analysis can be done this way as well, based on metrics and so on. So I guess my overall conceptual point is interfaces rather than tools are important. And my other point is automation. So you want to automate everything, remove the humans as much as possible. And obviously, at the end, you're going to need humans, and it's going to be alerts and fire situations, and we're going to be talking about how we meet the SLA and so on. But automation is key. It's one of the principles of DevOps, essentially. So I'm going to end with a few kind of, just a list of things. I don't even know, is it principles, is it kind of lessons that I've learned? But I'm starting with the humans. So empathy, because when you build a platform, so if you're in a position where you have to build a platform between dev and sysadmins, and you're serving business as well, you have to really understand everybody and where they're coming from, and you put yourself in their shoes. So empathy is key. Not necessarily sympathy, but empathy. So then customer focus is another thing. In our case, we have, the stack is essentially, there's business wants to do things, dev is helping them materialize those, DevOps is helping dev, and there's the ops guys are helping us. So our customers are up, so it's dev and biz is who we serve. And we got to understand their needs, not what they want, but what they need. And so by focusing on them, we know how to build what we're building. Working with quality is tricky. Some people say, perfection is the enemy of, working fast. That's true. It's not really about perfection, but it's about quality. So if you could actually slow down if you're not working with quality, because you're gonna have to fix things later. So there's a particular balance to strike between quality and speed, and it's important in my experience, in my view. And the other thing, you could actually achieve quality by adhering to some basic principles. There are a number of things out there that people talk about DevOps principles, immutability, automation, and so on. You could look them up, but like think of the principles when you do things. So like if you have stateless services, they should be immutable. They shouldn't be affected by a change or something like that, is one example. Another thing, interfaces I already mentioned, are more important than the tools themselves. You should, in my opinion, obsess with interfaces and nail them, sweat them, especially try not to leak abstractions. So for example, we are working with Linkerd, has delegation tables. There's the temptation to kind of expose that to the user, but we are not doing that because, well, we really work with URLs. A URL is a standard interface, and you don't have to leak that underlying abstraction. Otherwise, we have deep integration between things, and good luck migrating things from there if you want to survive in the long run. And finally, a couple of other things. Continuous improvement, you always strive for improvement, like learn from everything and improve, both technically and organizationally. And finally, and the previous speaker mentioned this as well, what you're doing is really you're helping your organization achieve agility. I know it sounds like a business word, but essentially that should be your goal and everything should follow from there. You're really helping your organization while you work there. You want to really help them. And you're very lucky if your organization supports you as well. So if you're doing DevOps without organizational support, something is not quite right. But if you're lucky to have full support from the top, then really you should be thinking of that and everything will follow naturally. And that's it for me. I don't know, probably no time for questions. I had a few other questions, but I think we should cut it and just talk later if someone is interested. Thank you.
Thank you so much, Kamen.